class, and welcome to lesson 5.2, special triangles. This will be some neat new triangles that you're going to know today, and these are things that as soon as you get your next unit test, I would write these special triangles on your top of your test paper so that you can help you be more successful on your unit test. But let's get to these triangles. First thing it says, consider a square with one length, unit length of 1. Okay, so what do we know about that? That means that all of these are 1. The diagonal creates two right isosceles triangles. So what does that mean, folks? That means that an isosceles triangle has equal length, but it also means it has equal angles. So for example, this angle has to be the same as this angle. And what do we know about when we've bisected a square, my fault, that each of these angles is going to be 45 degrees. So you could argue that, hey, it's the same on the other angle as, or on the other triangle as well. Okay, so let's just take a look at one of these, folks. And then it says to calculate the length of the diagonal. So the length of the diagonal, we could just let it be called C. Okay, it doesn't matter which triangle you use. Hopefully you recognize to use Pythagorean theorem because C squared equals A squared plus B squared. Subbing that in, you got C squared equals 1 squared plus 1 squared. So C squared equals 2. To get C by itself, C equals the square root, which is your opposite operation. And we're going to leave it like that, folks, because if you try to plug square root of 2 into your calculator, you will notice that it's called an irrational number. The decimal keeps on going and there's no pattern or repeat. Okay, so we're just going to leave it like that for now. So we're going to take and transfer that information down into this triangle here. So what do we know? We know that the two side lengths on the outside are unit length of 1. We know that the diagonal is 2. And we also know that the angles are 45 degrees. Awesome. So now what we can do is now we can calculate the sine, the cos, and the tan of these of this special triangle. Now here's a hint for you when you're looking at your unit test or homework questions. When it says exact values, folks, that gives you a key to tell you that it's special triangles. Okay, and you'll see that maybe even on your final exam. Okay, if they say exact trig ratios, that means you're going to be leaving them in this format that I'm going to tell you. Now, I'm not expecting you to memorize all 3 of these. All I want you to do is to be able to draw the graph or draw the triangle, folks. And then once you've done that, then you can easily find the sine, cos, and the tan. Okay, so sine of 45, just remember, folks, that it's the opposite side, which is 1. I'll just show it, I'll put it in here for you. So opposite side over the hypotenuse. So that's going to be 1 over root 2. The cos of 45 degrees, that's the adjacent side over the hypotenuse, folks. And that again is going to be 1 over root 2. Doing the tangent, folks, that's the opposite over the adjacent, which in this case is 1 over 1, which equals 1. This is a special triangle because the sine and the cosine of 45 degrees is equal. And we call this a special 1, 1 root 2 triangle. Okay? If you had another triangle like this, folks, and we said this was 5 and this was 5, hey, these are 5 times as big, so this would be 5 root 2. Okay, or if it was 10, 10, this would be 10 root 2. Okay, so you can use the 1, 1 root 2 triangle and take multiple factors of it if you wish. All right, but that's later on coming, but just for now, just deal with the regular 1, 1 root 2 triangle. All right, let's take a look at our second special triangle today, and it's asking us to consider an equilateral triangle with side length of 2. So what do I know, folks? I know that this is 2, and this entire length here is a measure of 2. All right. Now it says the height of the triangle, which is right here, it creates two scalene triangles. Okay, what do we know about an equilateral triangle? We know that each side must be equal, but also we must know that each angle must be equal. And if we know there's 180 degrees in a triangle, we know that 3 times theta has to equal 180. So to get theta by itself, what does each angle have to be, folks? Theta has to equal 60 degrees. So I know this is 60 degrees. I know this is 60 degrees, but if at the top, if I split the 60 degrees into two equal spots, I know each of these has to be 30 degrees. Okay? If we are asked to calculate the height, which would be h, okay, we need to take a look with Pythagorean theorem. Okay? You would say 2 squared equals h squared plus half of this would be what? 1, right? Plus 1 squared. So to get h by itself, h squared equals 2 squared, subtract 1 squared. So h squared equals 4 subtract 1, which is 3. And again, to get height by itself, you take the square root. So root 3 is another one of those irrational numbers. So if you try plugging in your calculator, ladies and gentlemen, it gives you a yucky answer. So that's why, again, when we take a look here, we're going to have what's called exact trig ratios, because root 2 and root 3 are not nice numbers, and that's why we use them as is. We leave them as root 2 and as root 3. So let's transfer information to our second spectacular special triangle here. We know that this is 60 degrees on the bottom. We know this is 30 degrees on the top. We know that's a 1. We know this is a 2. And we call this root 3. Now, how I remember this, folks, because there's two different angles in this case, I always say that the root 3 is always adjacent to the 30 degrees. So 3 and root 3, I kind of put them together. All right. So taking a look here, folks, we've got some triangles to figure out here. Now, sine of 30 degrees. So to deal with the 30 degrees, I'll use this angle of reference. So to deal with the sine of that, it's opposite, which is 1, over the hypotenuse, which is 2. All right. To do the cos of 30 degrees, it's the adjacent, which is root 3, over the hypotenuse, which is 2. And to do the tangent, ladies and gentlemen, it's the opposite, which is 1, over the adjacent, which is root 3. Now we're going to change the angle of reference, because now it says for the 60 degrees. Okay? So sine in that case, folks, is root 3, which is your opposite, over your hypotenuse, which is 2. Okay, taking a look at the cosine of that, that's going to be, I apologize, I'm just looking back here, folks. I meant to put a root 3 in there. Can you please fix that up? Okay, so back on track now. Cos of 60, folks, that's going to be the adjacent, which is 1, over the hypotenuse, which is 2. And the last one, tan of 60, is root 3 over 1, which just equals root 3. Now, the interesting part about this, folks, is you should notice a connection. The sine of 30 equals the cos of 60. Likewise, the cos of 30 equals the sine of 60. This is another way we call this, or another reason we call this a special triangle, and we call this the 1, 2, root 3 triangle. So again, folks, I don't want you to remember all these ratios. I want you to be able to draw the diagram, and just key to remember that root 3 is always adjacent the 30-degree angle. All right, moving on, folks. Let's apply these to some problems now. All right, watch the wording here, guys. Determine the exact value of each expression. So as soon as we say exact, you know you're using your special triangles. So you may want to quickly just go 1, 1, 45, root 2. So you know that, okay? And you may wish to do 60, 30, and remember root 3 is there, 1 and 2, okay? So let's take a look at this. Example A says, or part A says sine 60 cos 30. Those mean to multiply, guys. So you're going to multiply those together. So first of all, sine of 60, go over to 60 here and take the sine. So the sine is the opposite, which is root 3 over the hypotenuse, which is 2. So this equals root 3 over 2 times cos of 30. So go to the 30 as your angle of reference up here. And cos of that, folks, is root 3 over 2. All we have to do is multiply it together. Root 3 times root 3 is root 9, which is really simplified to 3. And 2 times 2 is 4. So the answer there is 3 over 4. B part is a little more difficult because it's cosecant, and you just have to remember that the reciprocal of cosecant equals 1 over the sine theta. So it's 1 over sine of 45 degrees. Okay. So we're going to go 45 degrees and go the sine of it, which is 1 over, and then when you do this, folks, it's 1 over root 2. Remember, when you're dividing by a fraction, you invert and multiply, so it equals 1 over 1 times root 2 over 1, or just plug in your calculator as root 2 and see if it stays. It may not stay as an exact value. So your answer here is going to be root 2. All right. Last one for this part, ladies and gentlemen, we've got 3 tan 60. So remember, it's 3 times the tan of 60. So let's go to 60 and do the tan of that. So tan is root 3 over 1. So 3 times root 3. Subtract tan 30. So for 30 degrees, looking at your tan, it's going to be 1 over root 3. To simplify that, ladies and gentlemen, it's going to be 3 root 3, subtract 1 over root 3. Now, remember, when you have fractions and you want to add or subtract them, you need a lowest common denominator. So what we need to do is to get my first expression to be as a root 3. So whatever you do to the bottom, you do the same to the top. So you times it by root 3. Everybody okay with that so far? Okay. So 3, when we simplify this, 3 times root 3, ladies and gentlemen, is 3. So 3 times 3 gives you 9. So we have 9 root 3, subtract 1 over root 3, which equals 8 over root 3. Now that's almost complete, folks. You just have to realize that in this fraction in rational form, we have what's called a irrational number as a denominator. So we have to fix that. And this is a new thing called rationalizing the denominator. Okay, because we can't leave it as root 3, because how do you take a piece of pizza and have root 3 as a part of the whole, right? Doesn't make sense. So all we have to do is, I'm just going to rewrite my answer here. To eliminate a radical, basically multiply it by itself. So you're going to times it by root 3, and whatever you do to the bottom, you do the same to the top. So it's going to be 8 root 3 over 3. Notice now our denominator is easy to evaluate. We could take our pizza and put into thirds by example. All right? So that's called rationalizing the denominator. And that's whenever you have an irrational as a denominator. So the cases where you would do that for our special triangles is where you have a root 2 or a root 3 as part of your denominator. Okay? So just remember that step, folks. All right, last question, ladies and gentlemen, before we finish here today, is using special triangles determine the angle theta if theta is between 0 and 90 degrees. So it actually tells you to use your special triangles. Okay, so looking at this, we've got 6 sine theta equals 3 root 3. First thing we want to do is we want to get that theta by itself. So first of all, we're going to get the sine theta by itself. Currently it's multiplied by 6. You have to do the opposite, which is divide by 6. Whatever you do to one side, you do the same to the other. So we have sine theta equals 3 root 3 over 6. Look to simplify that expression, and I say, hey, 3 can go into 6 twice, and it goes into 3 once. So what am I left with, folks? Sine theta equals root 3, because it's 1 times root 3, over 2. All I do now, folks, is go up to my special triangles up at the top. Okay, go to my special triangles, and we need to have root 3 over 2, which tells me it has to be the sine of 60 degrees. So that means theta has to equal 60 degrees. Okay, so look at special triangles. Okay, good. Let's try the last one here. We want to get solve for theta. Currently, cos theta is multiplied by root 2. You do the opposite, which is divide by root 2. So we're left with cos theta equals 1 over root 2. What angle is that? Again, go look at your special triangles. And what do we notice, folks? You should notice that theta equals 45 degrees. Awesome. Great work here today, ladies and gentlemen. Here's our homework, page 287, numbers 4 to 8, 10, 11, and 12. Again, have a great day. See me if you need any help, and have fun doing your homework.